This video is created as assignment for PHY 5X7 given by Madam Siti Fatimah. In this video, we gonna share some information regarding the topic of nuclear fission and fusion. What is nuclear fission? It is a reaction in which an atomic nucleus of a radioactive element splits by bombardment from an external source with simultaneous release of large amounts of energy used for electric power generation. Spontaneous fission defined as the nucleus of a very heavy atom, which mass numbers over 230 spontaneously split apart to form lighter, more stable atoms. This is a type of radioactive decay. In large atoms, the electromagnetic force overcomes the strong nuclear force, then the nucleus splits. An element that undergoes fission reaction is uranium-235. Uranium-235 is a naturally occurring isotope of uranium metal. It is the only fissile uranium isotope being able to sustain nuclear fission.
The half-life of uranium-235 is 704 million years. This occurs very slowly, used for dating the age of the Earth. Elements that have masses over 230 are at the bottom of the periodic table. This slide shows the nuclear fission. Neutron hits uranium nucleus. Then, uranium nucleus splits into smaller nuclei and some more neutrons. Then, these neutrons hit more uranium nuclei. In this fission, a neutron is absorbed by a heavy isotope and it splits into two particles of uneven mass plus 2 or 3 neutrons and energy. The amount of energy released is called binding energy. Binding energy is energy required to keep the nucleus together.
Applications of fission. Nuclear power. Fission is controlled and nuclear energy released is transformed into electrical energy. This is the picture of applications of fission.
Fragment and leaderboard. Nuclear weapons is a fission releases neutrons that causes a chain reaction and huge release of energy which is bomb when not controlled. Fusion. Fusion is the combination of fusing of two lighter nuclei into one larger nuclei. It requires a huge amount of energy to overcome the repulsion between the positively charged protons. It is require heat 10 to the power of 8 Kelvin to causes fusion to occur. Fusion is what causes the energy from the sun and stars. Fusion releases much more energy than fission. The figure shows how the process of fusion occurs. Are fusion reactors available for production of energy? The answer is no. It is required too much heat to cause fusion to occur. All matter at the required temperature would be turned into a gas. The energy release is unpredictable and extremely dangerous.